Verilog is a hardware description language. It is used to design and describe digital codes, digital circuits like half adders, full adders, multiplexers, decoders, alarms, etc. Instead of drawing circuits with logic gates, we can write Verilog code to describe how the circuit should behave. So the next question arrives, why Verilog is used? Because Verilog is used as Verilog helps us to test our design in software. We can see after simulation how our circuit will work, and also it is time saving because instead of manually designing the circuits with hundreds of gates, Verilog makes it easy to write short code to describe the complex system. Now we are going to take a simple example or application of OR gate. We know that in OR gate, if both the inputs are low, our output will be low, and if any one of input is high, our output will be high. So let us take an example of car door. Suppose there is a four-wheeler, we will have four doors: front left, front right, rear left, and rear right. If all the doors are closed, then my alarm will be off. If any one of the door is open, that is any one of the input is high, my alarm will be on. So now we are going to design this circuit using Verilog. Now let us start our coding in Xilinx software. The first step to do is to create a new project. So I will click on file. I will select new project. Here I will have to give name for the project. While giving name, there are few rules which we have to keep in our mind. First rule is that we should not use the special characters in our project name. We should never start our project name with digits. These are two rules we should keep in our mind. Now I will give name to my project as car alarm door system. Now we are using here we have to select the type of top level source for the project. Here are other option also, but we are using HDL, hardware description language, so we will click that, and after that the next step is to click on next. These are properties of my PLD. PLD is actually array of AND and OR gates which are surrounded by the other gates like flip-flops and everything, which is again a NAND gate. So these are specifications of that. This is product category, family of that PLD, device name, package name, and speed. To check our syntax, we will have to use synthesize tool. So here we are using Xilinx synthesize tool, and simulator we are going to use ISA simulator. So I have selected this. The next step is to click on next. After clicking on next, I will click on new source. Here I will have to add VHDL Verilog module, because if I don't add that module, then my code will give error. Now I will give the name here. For giving name, we have to keep same things in mind while we wrote the name of our project, that our name should not start with digit, and second thing is it should not contain any special character. Now I am giving name as car alarm Verilog, and add to project is very important. Next I will click on next. Here I will have to give inputs and outputs. As I told you, we will have four inputs. As a car has four doors, we will have the four input. Now I will give name of inputs. Port name, port is the keyword we will use, and here we are selecting mode. Firstly I will write name front left, front right, rear left, and rear right. Last one is output, that is alarm. Mode of these four is input, and mode of alarm will be output. I am not using any bus here, so we will not click on that. After this I will click on next, finish, next, next, and finish. Here I will have to write the code. So I will write the code here. I have written my code. Now let us see what I have written. In first line you can see I have written module and car door alarm system module. Module is the keyword and car door alarm system module is the name of my module. So the syntax of writing this is module, name of the module. In this between parentheses we will have to write inputs and outputs. After that we have to write the statement or assigning out output or interconnecting our output and input or giving a relation between input and output. So here I have written module name and a keyword module name, keyword input, as these are my 4 inputs, and alarm is my output. In this line I have written this is my comment line, so it is not going to display anywhere, but it is for just understanding that it will work only when my alarm will work only when any of the door is open. Here I have written assign alarm is equal to this thing. Now I am using OR gate. So I have written assign is keyword, assign output is equal to OR of this input, and at last I have written end module. This is compulsory. Here you have to keep one thing, understand one thing, that here you don't have to write the name of the module, you simply have to write end module. Now I will save this. After saving this I will click I will add new source. From here I will add verilog text fixture. I will give name, add to project is very important. Next and finish. Here I will have to write the code for my test bench. Now I will write that. I have written my code. Let us see line to line. First I have written keyword module, the name of that test bench fixture. Here I have given inputs again. Inputs are REG. REG stands for registers, which means nothing. They just act as variable which store some value. So REG front left, REG front right, REG rear left, and REG rear left. Here these are inputs, and output is always shown in wire. So it will be it is written as wire keyword and then output name, that is alarm. Here instance of my code is created. UVT is nothing because we can use anything there. There is no need to use UVT only. It is the instance name. It can be anything. After that I have written keyword initial begin. In this I have initialized the inputs to 0. Here I have written monitor changes, means whenever input will change, then output it will automatically make changes in output also. My simulation will be stopped or it will wait, compiler will wait for 100 nanoseconds. After that it will open front left door, it will close that. After that it will open rear right door, then close that. Similarly it will open these two and then close that. After that finish simulation, and I will end the module. After this I will save. I will again add one source, new source, and I will add test bench waveform. Here I will give name as test bench text bench alarm system. Add to project, then next, finish. As my circuit is combinational, I will click on combinational, then finish. And here we will have to give the input. First we will give 0, then we will give 1, then 0 0 1 0, then we will give 0 0. I have given input here. Now I will simply save that and close that. After closing, I will click on this behavioral simulation. I will select test bench alarm system. I will click on this. This is how we will get our output. Here, if my inputs are 0, means if all my doors are closed, my alarm will be also off. My alarm will be also off. If any one of them is high or any one of them is 1, then my alarm will be 1. You can see there. My alarm will be 1. So this is all about today's video. I hope you all have understand everything. Thank you so much for watching.